Hello, everyone.
Hello there.
Hello.
Hello.
Oh, hello.
Are we ready?
No.
Define ready,
Okay.
but kind of.
Our program for tonight will have presentation from your projects, and then in between, we'll have an assignment that is part of our in-class projects. It is Pulse with Modulation program that you will be doing. And I believe we may have another in-class activity. But for now, is there any group that is ready?
Can I go first and get it over with, and then I can die?
Okay, okay, go ahead.
All right. Let's see if
By the way, when you finish, you are more than welcome, and I encourage you to stay and listen and watch others' ideas, because that is part of our educational program to learn and see how others are thinking and developing their projects. Thank you. Please go ahead. You may share the screen.
So I'm a bit underprepared. I apologize for dedicating more time to this one. But this is what I should.
I need first to speak about the program you are developing, the project you are going to present, and then show us the code, and you will go through the codes step by step, very slowly. Finally, you run the project.
Well, I had a compiling error when I tried to load it, and I can pull up what I have and show you what I was planning on doing. And then I need to share this on my laptop here in a second. December 10th project.
Recording in progress.
Okay. So let me share this screen. Share. All right. So this is what I was hoping to accomplish, but I didn't get it finished, so I apologize about that. But anyway, since music has a specific frequency that we can get from period divided by 2, you can set up that formula and calculate all the frequencies for standard music code. And then I was hoping to build a melody using just a standard array and using these frequencies, which is defined up here. And then hopefully I was designing this for a speaker. So I was setting my pin LED output. It's setting my initial state at low for pin 13. And then I was going to have a wire hooked up to a speaker. I didn't think we were going to use the circuit playground, but anyway, that's what I initially started out with. And then I wanted to use this code, which is just the Java version of setting my inputs and outputs using the same frequencies here for each ringtone, setting them all high. But I found a compiling error when I tried to load onto my board. It won't recognize what it is, and I don't know what the problem is. So it says it can't find the board selected port, but oh, wait a minute. Get board info. Adafruit. Anyway, I was having trouble getting it to compile, and what I originally wanted it to do was use something like not that one. I found this tutorial on how to set up for pin inputs and outputs for the Adafruit here, but I didn't get around to compiling it. So I was hoping to use something like this with a digital read and write to each of the outputs, but anyway, that's what I've got.
We are working in digital system. Digital system is binary. That means 0 or 1, true or false, program running or not running. You have 3 more hours to figure out and resolve the issue. I need a running program.
Yes, sir. So it says here, couldn't find, nope, not that. Anyway, I've got an error and I'm trying to figure out what's going on.
Okay. You have 3 hours, work on it. Okay?
Yep.
Thank you. But the idea is great. I like the idea.
Thank you.
Any other groups?
Yeah, me and Benjamin can go now, I think.
Okay.
I think I can do the bulk of the presenting. So let me bring this
Who
up.
is your partner?
It's me, Benjamin Schroeder.
Okay.
All right, so let me go ahead and share the screen and get this going. So here we go. So assuming I can, yeah, it looks like you can see the Arduino IDE here. So our program in brief, and then I'll walk you through the code. It measures the color of an object directly in front of the board, and then not only tells you what that color is, but also changes the lights on the board to that color. So we start up here with our includes and some of our process and global parameters, and our function stubs, or function prototypes. You know, assigning the serial sets. We have an initial message here to tell the user about what this program is about to do. We set up some internal values, and we give another message. And we have some control logic to wait until the user enters anything into the serial communications, and then it will proceed once anything has been entered. And then we call the main function here, which is called find color. It's going to display the RGB color code of that color. And we also have an additional output from that function, which is the estimated color it thinks it is. So that's red, green, blue, yellow, cyan, or magenta, or some unknown parameter that it doesn't know. And so now the primary logic here for this uses three arrays of some predefined sample depth, which we set to 100 in this case. And essentially what it does is it calls this other function called color scan. which turns the lights of the neopixel onto red, green, or blue, and then measures 100 samples of the reflected light intensity. And so back in here, we can then essentially high pass filter it to get rid of some of the random quantization noise, because it ultimately is reading in as an integer, and that can have some dynamic range problems. And then we can take the mean as a low pass filter and subtract it from them to get a relative color measurement. And then from that, we can easily process that to attempt to figure out what color it is. And in this case, we actually do a normalization from whichever color was the maximum, which just helps us with the dynamic range a little bit more. And then we map that to a 0 to 255 value for just conventional RGB color coding, which is 0 to 255, or 0 to FF for each channel. And then there's a little bit of a color selection algorithm here. Once that's been found, we go back to our main function. Once that's been found, as I mentioned here, it will tell you what that color is, and then it will repeat and ask you again. So I will now stop. Actually, no, I'll now bring up the serial monitor and begin sharing video of this. So let me move the camera to the correct location. So 1 moment as I put the camera right in there. So let's reset that and go to start video. And here it is. So you'll have to see the device here itself, and in the you also have to watch the share screen for the actual prompt that it's giving us. But now we take this red object here, this red piece of paper, and we hit enter. It's going to go ahead and scan it. And as you can see on this, it determined it to be completely red, zero other color aspects of that. And the LEDs have changed to red as a result. So now, if we try this for green, it will scan again. And we can see it's identified as green. And we can rinse and repeat for this blue color, because that's its job, and it does it pretty well, we found. So as you can see, it detected blue. You can see all 3 color readings here on the serial monitor. And yeah, that's our project. We think it came out pretty well.
Oh, very impressive. Thank you.
Yeah, thank you.
That's a really cool concept. I like what you guys did there.
Yeah, but
Yeah.
color graded reflectometry.
Yeah, there you
Uh, would you please upload it? Both of you, I need you to upload first.
Sure, we'll just take our code and throw it into the. Do you want the sketch or a PDF of the code?
Yes, it is a PDF, including the code, including this little demo as a video clip. I need just the link of the video clip that you are gonna record.
Sure thing. We'll get that to you as soon as possible.
Okay. You have with this upload up to tomorrow night. You may upload it up to tomorrow night. Okay.
All right, thanks.
Thank you very much. Who is next?
I can go next if you like.
Okay, go ahead, please.
All right, let me show my screen.
Are you alone?
I am with Brandon. Sirik. I'm sorry if I said it wrong. Sirik. How do you say Brandon? Sorry. I'm sorry if I butchered your last name.
Okay.
All right, so this one probably is gonna help the gentleman that was at the beginning. So we also did a program where we are using buttons 4, 5, and the slide switch 7. And we're using them to play Christmas songs. So we have 3 Christmas songs in there. And I was taking the route that the first person came in, and it didn't work. So I had to do some research, and I found out that I have to use a file called Peaches. So as he was trying to lay out the notes, you add a second file defining all the notes that are needed. So that way, when you call them, they're going to be ready in the program, so you don't have to, because if I had to do it the other route, it was taking too much memory and will not let it play, which just crash. So that's what I had to do. So I included the file pictures, and that's my playground. This is my speaker, A0. So that's gonna be my first song. The other hardest part was to find the melody. Like he was setting it up, I was doing exactly the same thing, and I did more research, and I had to do as an integer, I'm sorry, and I had to include the melody the way they have it. That's the first one for Jingle Bells and the tempo to see how it's gonna, the timing and how it's gonna play out. The second one is we wish you a Merry Christmas. The same thing, I had to do the melody and the tempo. And the last one is gonna be Santa Claus Coming to Town. This is where I'm initializing my buttons. There's gonna be button 4, 5, and switch number 7. This is my first setup. So here I'm declaring my pins. So that's my speaker for some output. I was using 13 as well to just to make sure it was running. I'll also be using the NeoPixels. So when the song is playing, the NeoPixels are gonna show a color theme close to the Christmas song. So I'm using pin 4, which is my button 4. As declared as a input pull down. We did switch 7 as a pull up. And switch 5 as a pull down. So this is the first void loop. So I'm declaring here my buttons. Button 4, digital read 4, 5, 5, and 7, 7. I have a few if statements. So if 4 is 5, we're gonna play song number 1. And then we're gonna print button 4. And else if we press 5, we're gonna play 2. Print button 5. And if we slide switch 7, it's gonna play song number 3, is gonna print slide switch 7. So I'm declaring it as 0, my songs. So this is one of my first melodies that we're doing. So declare as a song. So we have a few if statements for the for loop. So if the song is equal to 3, so we're gonna print Wish Merry Christmas. This is the size of the melody. And this is the for loop. If we're gonna start the note at 0, if then this note is less than the size of the note, then we're gonna keep increasing the song. That's the duration. That's how we find the duration. And that's the tempo divided by the tempo. And this is for the buzzer, the melody looping, wish the melody, and then the duration. And then this is the pauses between the songs. And these are the LED pixels that are gonna play, or they're gonna light up when the songs come on.
Nice, dude.
And this we're doing the similar thing with song number 2 and song number 3. So I feel like I can play it right now if you want to see it. Let me turn on my camera. All right, so where's my camera?
Yeah, I think ideally we'd have an off-board speaker because onboard one's pretty tinny.
You have it? Can you do it? Oh, what do you mean? What did you say? I'm sorry, I didn't hear. Let me turn on my camera.
Yeah, I've used it. I've used the speakers for some of those, and they don't sound great. But yeah.
I mean, yeah, it is kind of bad, but I mean, I'll show you. Well, let me press. This is gonna be button number 4. I can turn on the camera. Oops, not turn it off. Where is it? Where's my name? So, start video. Okay, here. See it? All right. So I'm gonna press button number 4 right here. Can you hear it? So, and then it prints button number 4. I'm gonna press 5, there's a 5 right here, 5.
Very good, Ben.
And it's gonna print 4, and then I'm just gonna use the slide button on the bottom right here. So that is hard to see, but the little one. There we go. Here. I have to bring it back as a pull up, so if I don't turn it off, it's gonna keep on playing. Where's it? Right here. And then it prints a slide switch number 7. And that's about it. That's all we got.
Very cool.
Yeah, it is very cool.
Thank
Yeah,
you.
good job.
Thank you, guys. Appreciate
I
it.
really like how you use the pitches.h function header file as a lookup table.
Yeah, because it was a mess. I was trying to do it the other way. It was just crashing. It was too much. Remember, how did you mention it that you're gonna have enough RAM to run it? And yeah, it didn't. So I have to find another way to incorporate it so it won't crash. You know?
Yeah,
It was
lookup
too much.
tables are the way to go for that. Yeah, for sure.
Yeah. Hmm.
Okay, great. Thank you. Do we have any other projects?
I can go next.
Okay. Who is your partner?
Brandon Dickerson, and then we're gonna share and combine forces with Ben, and you know, compare and contrast and go from there.
Okay. Go ahead, please.
All right, move that. Okay, so the goal of our project was to create a like a digital level using the accelerometer data, the accelerometer built into the Arduino, and so as you rotate and tilt the Circuit Express, it will light up the NeoPixel LEDs to show the orientation of the board. So to do that, began by declaring some constants for using a moving average, and then some samples on that. So we're declaring some constants that we're going to use throughout the code, and then also declaring some global variables, some arrays for collecting samples, and arrays for determining the rate of change between those samples, as well as just some other variables for the mathematics, the arithmetic operators, and decided to use global variables for that for simplicity, rather than having to pass and return variables for in between functions. Just did it globally. So initial setup is just a normal initialization, beginning the function for circuit playground, serial, all that good stuff. And then we jump into the main function. And for that, so it begins with a for loop that is going to collect all of the samples. And so starting at 0 and then to sample size minus the boundary for the averaging. Every time that loop is restarted, initialize the variables back to 0. So it's a fresh set of values for the moving average. And then from there, we jump into another for loop for that actually is used for the averaging. So we're first finding the sum of all the data points. And so that's looping through. Again, we're using that moving average. So finding the sum of that and then dividing that sum by the length, or the length of the averaging window. And that gives us the average. And then from there, per your recommendation, also added in a feature that if the Arduino is moved around a lot, the rate of change is very fast, it will alarm and alert the user that the rate of change is higher than a set threshold. So that's doing it on every axis, the X, the Y, and the Z axes. And that will alarm both on the serial port, and it will create a visual alarm as well as just light up all the LEDs. So it's just letting you know it's inaccurate, not too fast for this application. It's printing all of the data points to serial, so you can see it. You can see it on the graph, see it on the serial monitor. And then we're using just if else statements for depending on the orientation of the board that it's taking from those averages, setting, and then with some predefined values for the orientation, lighting up the NeoPixel LEDs that are at the bottom of the board. So it's just a bunch of if-thens going through that. And then at the very end, it clears all the pixels so that it can restart. And then there's another function that is used to print all of the average values to the serial monitor. To yeah, just make it kind of cleaner there. And so that's the code. And then let's see, start video. Is that showing? I can't see myself. There it is. Okay, so I have to open up serial. So maybe work better if I turn off the light. So it will, okay, if you see that, so as I rotate the board, it lights up the LEDs that are at the bottom of the device. If it will focus. And so the leveling there works. Let me turn off, let's see, background, maybe that will help. Where is that? Video, background effects. So that helps. So it will, yeah, light up the LEDs that show an orientation of the board. And if you change the orientation fast, it will alarm. So that was our project. Oh, and then if you lay it down flat, it will light up all the LEDs and all of that.
Cool. The accelerometers on these things are exceptionally finicky sometimes. So that was an ambitious one.
Yeah, I think the averaging actually really helped out with that, because yeah, it's moving around a lot, and I think the most challenging part was getting the using the moving average in a way to also calculate out the rate of change for that alarming. Any questions?
Okay, great. Thank you.
Thank you.
I'll speak a little about our in-class activity. I will share the screen. We'll be speaking about the pulse width modulation. If I have a DC voltage, this is V, and this is, for example, 5 volt, constant. If I feed this to a light emitting diode will lit constant, no change. If I wanna increase or decrease the light intensity, I cannot do that. If I have a DC motor, the DC motor would run at a constant speed. I cannot change that also. What will happen if I have this waveform. This waveform is still DC, but instead of having it on all the time 5 volt, and if you measure it, you are gonna see that your voltmeter is reading 5 volt. But with this scheme, I am turning it on for 50% of the time and turning it off 50% of the time. So I expect here the average that you can measure, it is going to be 2.5 volt. The motor will run at half speed. And the light intensity of the light emitting diode, it will be half. So I can control that. If I can also have it like that, the ratio between on to off is now lower. So I can control the speed, I can control the light intensity. In our project tonight, the pulse width modulation, I have already some of the pins available on your Arduino kit that are ready for pulse width modulation. So I'm gonna use those or program them. And as you are gonna see from the handout, I can give it the ratio between the on and off. I tried it myself, and it worked just fine. When I tried it on pin 13. I managed to control the light intensity of pin 13, that is the default, or you can use it to any one. But in this lab, we are gonna go further. Just program it for now for any one of the new pixels that you have and play with it. But I hope that by the time you turn it in, you can speak to the outside world. How? You can send this to one of your output ports that can be programmed. And on the output port, you are going to put an external LED in series with a resistor. I'll have here a resistor, and this is my light emitting diode. This light emitting diode will be taking from ground and one of the ports. If you have this at home, that would be great. If you have at home a motor, you can put a small, very tiny DC motor. No, don't burn out the Arduino kit you have. I'd rather that you use LED. But we are going to have another experiment that we are going to be using small motor, and we're going to use a relay just to take the output and feed it to the motor. But for now, please read the in-class activity and think about it and start programming it. And I'm going to give you about maybe 30 minutes to work on it, and we'll be back.
Which in-class activity is this?
Is this for topic 3?
Let me show it to you. This is our home screen. Topic 1, topic 2, topic 3. This is topic 3 in class activity, pulse width modulation. This one, I want you to start reading and working on it. I need to restart my computer. So I will end, but you still may log in back and you can share the screen. So when I end, you will might be logging out, but if it happens, just please log back in again and start sharing the screen, speaking with each other, helping each other. I don't mind working together at all. I encourage that.
Hey, Professor,
Yes, sir.
would it be all right if you took a look at this error? I need some help with that, if it could be possible.
This project.
It's not
Oh,
a coding error. It's not a coding error. It's a connection error to the board. So it has nothing to do with the code. I'm using an example code that should work 100%. It's just not connecting to the board, and I don't know why.
Okay, when you start again, please share the screen and discuss it with everybody around here. But I have to restart my computer. Okay.
Has anyone seen this before? Programmer is not responding.
Have not.